Oh, hello, human. I've been wanting to talk to you, actually. I've been talking to some cats that study humans, and apparently you guys help us in some way. They said something about our food only being there because of you or something like that. And so I was thinking, if you guys help us, we should help you in return, maybe. One thing I've noticed is how busy you humans are. I don't know what you're doing all day. I think it would help you out a lot to just sit and think about things for a while. And so I thought I'd share with you something I was thinking about recently. I was thinking about animals. If you have some animals, suppose you have a cat and a dog together. The animals interact in a way that almost forms a new animal entirely. It's as if the animal group is an animal itself. And I was thinking about that. I was thinking, is there really a big difference between animals and groups of animals, fundamentally? When I think about these kinds of things, I find it helpful to introduce a kind of notation for it, so that in my head I can visualize what I'm thinking about. So I thought I'd explain this to you. That might help you if you start to think about your own things. So for this situation, we're thinking about animals, and suppose we have a cat and a dog. We want a notation for the group containing the cat and the dog. And so what we're going to do is we're going to put a little plus symbol between them, and that will refer to the group containing the cat and the dog. At this point, we can list some of our assumptions, things we notice in our abstracted system that are also true for the animals themselves. Now, one thing you'll notice is that if you have a cat and you add a dog, you will get a group containing a cat and a dog. And it's the exact same thing as if you have a dog and then you add a cat. And so we're going to put that in notation. What it means is that if we take an animal A and B, then A plus B is equal to B plus A. Now, the next thing to consider is kind of related. If I have a cat and a dog, and we put them in a group, and then we add a sheep to the group, we will get the same thing as if we put the dog and the sheep in the group, and then add that to the cat. The next thing we're going to define is the fact that you can kind of think of a group of containing no animals as still an animal group. It's just the only animal group that can't be written as a sum of one or more animals. Having a group with nothing in it is still a group, really. Or at least for the sake of what we're doing, we're going to consider it a group. And we're going to call it the zero group. An interesting property of the zero group is if you add it to anything, you still get the exact same thing that you started with. The next thing we're going to assume is that there's no collection of animals which resembles the zero group other than the zero group itself. Another way of putting it, every group of animals with at least one animal in it behaves in some way, right? It's not going to just be dead still. The next thing we're going to assume is as follows. Imagine that you have a cat plus a group, and suppose this is equal to a cat plus another group, then those two groups are actually one and the same. And this makes sense, right? Now there's actually not much more that we have left to assume. All I'm going to assume is that we have a finite number of animals. Okay, so now we're going to show that animals are fundamentally different from animal groups. Despite my hypothesis that they're similar, what I've come to realize is that there is something fundamentally different about animal groups if we take this list of assumptions that we've assumed. And the property, or at least one property that the animals have that the groups don't have, is that if you just take the animals, you can get any animal group. However, the reverse is not true. You cannot take an animal group and get an animal. So imagine a universe where every animal could be written as a sum of animal groups. Another way of putting this is that every animal is equal to a sum of some other animals, but where there's more than one other animal, right? Obviously, every animal is equal to itself. That doesn't count. What we're saying is we can write the animal A is equal to A1 plus dot 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 plus AN for any animal A. So, for example, maybe a cat is equal to a giraffe plus a hamster plus a baboon. Obviously, this isn't true. What we're going to show is that it isn't true, but we're going to imagine a universe where it is true and then show that that universe would be nonsense. So, to start off with, we're going to take an animal. Let's say a cat. Meow. So we'll write the cat as equal to animal 1 plus blah 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 plus animal n. Now it's important to notice here that since a is equal to a1 plus plus an, we cannot have any of the a1 through an are equal to a. And the reason for this is, suppose that a1, for example, was equal to a. What we can do is we can use that 0 element we talked about earlier. So a is actually equal to a plus 0. And then we can use that cancellation property to get that 0 is equal to a2 plus plus an. And this actually violates one of our other assumptions, which was that there's no collection of animals that behaves the same as the 0 collection if it contains more than one animal. So we can't have that. So all of the a1 through an are actually not equal to a. And that kind of makes sense if you would have a cat and you wrote it as, a rhinoceros plus a giraffe plus a deer plus a cat. Well, it doesn't really make sense, because then the rhinoceros plus the giraffe plus the deer behave like the 0 group, which wouldn't make any sense. So that's great. We know that a1 is not equal to a. However, remember that our assumption here is that we're in a world where every single animal can be written as a collection of more than one animal. So in the same way that we wrote a is equal to a1 plus plus an, we can write a1 is equal to a11 plus plus a1n. And we get the same conclusion that we got before. Each of the a1, a1, 2, a1, blah, 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 none of them can be equal to a1 for the exact same reason. And notice that we can substitute this into the other equation. So we get that a is equal to a11 plus plus a1n plus a2 plus plus an. The point is here that we can then apply the logic we used in the first statement, and we know that a11 is not equal to a, and it's also not equal to a1. However, a11 is also an animal, right? So we can do the same thing to it. We can expand it out into a group of more than one animal, and we'll get a111 plus a bunch of other things is equal to a11. And using exactly the same reasoning, a111 is not equal to a, it's not equal to a1, and it's also not equal to a11. And we can apply this logic forever. What we'll find is if we can apply this infinitely, then that means there must be infinitely many distinct animals, which is a violation of one of our assumptions. And this conclusively proves that this is nonsense, and animal groups do not have the same property as animals, which is that the entire system of animals and groups, excluding the 0 group, can be written as a sum of animals, but they cannot be written as a sum of animal groups. Now, human, hopefully you have found this very enlightening. Hopefully you will still provide us cats food. We really appreciate it, or something. Yes, food sounds nice. Maybe I'll have some food soon. Or, I wonder what if we hadn't assumed that cancellation assumption. What if a cat and a mouse together could behave the same way as a cat and a hamster? A hamster would be tasty. But maybe the cancellation assumption isn't true. I wonder whether animals are still the same as animal groups if we don't have the cancellation assumption. Maybe we would need to figure out something else about the animals that would allow us to arrive to that conclusion. Maybe there are other assumptions needed. I don't know. I will have to ponder this greatly. I will see you another time, human.